Okay, next for our similar polygons, we want to take a look at the areas of the similar polygons. So I have the same two rectangles that I had for the previous example, a 2x3 rectangle, enlarged or dilated by a scale factor of 4. Then it becomes an 8x12. And maybe you're thinking, well, kind of like with the perimeters, then wouldn't the areas just be like 4 times as big? The area of this be 4 times as big? I don't know. Let's check it out. So the area of this rectangle, 2x3, pretty easy to figure out. 2 times 3, the area is 6 square units. So the scale factor is 4. Maybe you're thinking, okay, then this should be 4 times as big. 8 times 12 is actually not 24. 6 times 4. Okay, but 8 times 12, 96 square units is the area of this polygon. Okay, so the area of the similar polygons is actually not the same as either the similarity ratio, the scale factor, or the ratio of the corresponding sides. But that actually leads to theorem 8.2. Here's theorem 8.2, the area of similar polygons theorem. You have two polygons that are similar, like in our example above. The ratio of their areas is equal to the squares of their ratios of their corresponding side lengths. So here's what that means. Okay? If I'm taking a look at the ratio of the area of the image to the pre-image, the ratio of the corresponding side lengths is 8:2, or that's also the same as 4:1. Then the ratio of their areas, you actually want to square each of these corresponding side lengths. So it should equal 4 squared over 1 squared. Or in this case, 4 squared is 16:1. Because if you multiply 6 by 16, that gives you 96. So that's the ratio of their areas, the square of the similarity ratios. If the similarity ratio is A to B, then the ratio of the areas, as long as those two figures are similar, would be A squared to B squared. Okay, you square each of the corresponding side lengths to figure out the ratio of the areas.